So the integration by paths is basically one of the most important methods that is definitely helpful to solve the differential equation or any core questions. So the first thing is that understanding what is by paths. Now, when you have, let's say, two functions, let's say multiplied together. Now, for example, if I'm integrating x times sine x, now I don't have any direct formula for this. So the silly mistake that the students do is they just write down it as x squared by 2 times cos x plus c. This is wrong. Don't integrate them separately and then multiply the integral. That doesn't work. So what we got is a formula that basically allows us to integrate when you have got product of two integrals. Let's say when you have two integrals, we take a formula which is uv dash dx integral will be uv minus integration vu dash dx. This formula is also in a data booklet. Let me just decode what u and v stand for. V dash stand for here. So u, one of this function will be u, another function will be v dash out of these two. Now u dash is obviously the derivative. So now the first challenge that comes is how do I choose which one is my u and which one is v? Okay, so there is a general, like, not so universal method. Either some teachers take Eilert rule and some take Liat rule. That's up to you, whichever you want to use. Mostly both of them work in most of the condition. So let's say if I take Eilert rule, now I stand for inverse trig, L stand for logarithmic function, A stand for algebraic, T stand for trig, and E stand for exponential. So if I got something like tan inverse, sine inverse, cos inverse, if I stand for, let's take ln x or log x, if I take algebra, any number or any algebraic expression like x cube and so on, trig, obviously, e is the exponential like e raised to x or a raised to x. Now, what is this basically? Is to choose out of these two, which one is u. Now, out of this, whichever function comes first, that is your u. Now, let's take an example here. Now, let's say x is an algebraic function, and this is t is the sine x is a trig function. So algebra and trig. Now, when you look at algebra, it's coming first, so that becomes my u value. So u is actually x, and the v dash, that is nothing but the sine x. Now, the good thing is that identification of this help us to quickly put the values in the formula. So I need u, I already got u. I need v dash, I need v. So what I have is I already got v dash. So v will be nothing but integration of sine x, which is negative cos x. Now what you can do is you can think of putting a constant c, but like the thing is that you're already integrating, so you can put overall constant of this integration towards that. So v dash, so v is negative cos x. Now we got to do u dash. So u dash is nothing but 1. So let's just plug in the formula and see what do we get. So let's say what we have is integration of x sine x. What we have is x sine x is uv, which is u is x times v is negative cos x plus vu dash. So it will be negative cos x. This is minus actually here. Negative cos x times u dash, which is 1. So u dash is which is 1. So what we get is towards the end is negative x cos x, and this minus and minus become plus integration of cos x dx. So when I integrate cos x, I get is negative sine x. So negative x cos x, I mean positive sine x, not negative sine x, it's positive sine x. So overall, the integration of this actually got is by this method is negative x cos x plus sine x plus c. So this is the general logic to do this kind of questions. Now, when you have the other type of question, like now these are the types of question that that is something which is you don't see this rule very straight away. So, for example, if you're integrating ln x, now I'm just going to quickly take integration of ln x. I'm going to take other integration will be e to the power x sine x to explain this. Here it is solved already. So whenever you don't see like the integration, like two of the factors here, or two of the product numbers, so you can take other thing is 1. And since 1 is a number that is algebraic number, so what will be happening is that if I take uv dash dx is uv minus vu dash dx. So now out of this, if I apply Eilert rule, I stand for inverse, L stand for log. So log is coming first. So u is my actual log x, ln x. So automatically v dash is 1. What I need is u dash, which is 1 over x, and I need v. So v is x. So just plug in the value. So uv, so u and v, so u times v, that is nothing but, so integration of this will be u times v, which is x ln x, minus integration of vu dash. This is actually vu dash. So v is nothing but x times u dash is 1 over x. This cancels out and you get x ln x minus 1, minus x plus c, because integration of 1 is negative x here, I mean, because of this minus. Now, so this is the integration of the ln x integral. Now, for example, there are some cases you'll get 2 times, you got to apply the integration by parts 2 times. Now, I'll just, before I take this example, I'll take a quick example of x squared sine x here. So if I apply Eilert rule here, what we get is I stand for inverse L log A algebra T trig and T exponential. So A is coming first, so that is U. So U is x squared and V dash is sine x. So now what I need is U dash, which is 2x, and I need V is negative cos x. So first thing is that you plug in the formula UV, which is x squared times negative cos x, minus integration of 2x, which is u dash times v, which is negative cos x, dx plus c. I mean, I haven't finished the entire integration, so we'll do it negative x squared cos x plus 2x cos x integration. Now, what we got is that once again, we end up getting a part which needs to be integrated by parts. So in this case, what we do is we take, once again, this is my algebraic, so it comes first. So x squared cos x plus, now I'm not doing separately, but just in case if you're getting confused, u is nothing but 2x, so u dash will be 2. V is nothing but cos x, v dash is cos x, so v will be sine x. So now I'll take the integration forward. So uv, which is u times v, which is 2x times sine x, plus, I mean minus, this is going to be the derivative of this is 2 times the derivative or integration of this v is nothing but sine x. So what we get is eventually the integration is x squared cos x plus 2x sine x and minus integration of 2 sine x is negative 2. I mean, negative 2 cos x becomes, the integration of sine x is negative cos x, it will become positive plus c. So this is how you do the 2 times integration. And this is one of the example in mind map that I've taken here. So I have this is understood. Now taking the last example on this, which is integration of e to the power x sine x dx. So when you want to integrate e to the power x sine x dx, what we do is basically, once again here, I start with Eilert rule. So I stand for inverse L log e A algebra T trig and e exponential. So here t is coming before exponential. So u is sine x and v dash is e to the power x. And writing the formula once again, uv dash is uv minus vu dash dx. So this is the formula that is the general one. So now what I do is I take so v is nothing but e to the power x, v is nothing but e to the power x, and u dash is nothing but cos x. So let's start with this. So uv, so u times v, which is sine x times e to the power x. So sine x times, let's say, e to the power x, I get here. I'll take just one part here. So e to the power x times sine x minus vu dash. So v is nothing but e to the power x itself, and again u dash is cos x. So what we get is once again integration that I have to take it as by parts. So I again do the same thing. U is nothing but cos x here. So u dash is going to be negative sine x, and v dash is e to the power x. So v is nothing but e to the power x itself. So I'm just going to put this value here. E to the power x cos x will be integration will be uv, which is this cos x times e to the power x, minus integration of e to the power x times negative sine x. Now what I do is that if I take that here, e to the power x cos x plus e to the power x sine x dx. Now this thing I'm going to substitute back here. So I'm just going to write down one final step, which is e to the power x sine x dx will be e to the power x sine x minus, this integration is e to the power x cos x minus this, because this plus and minus becomes minus, so it is e to the power x sine x. And now what you notice here is that where you started from, you come back to the same step. So if I move this to the left, what I get is obviously put a c here now. So it becomes 2 times integration of e to the power x sine x dx is e to the power x sine x minus e to the power x cos x. And if you divide by 2 here, and so what you get is this part plus another constant c. So this is how you do the integration where you got the repetitive integral 2 times. And in that case, you have to do integration very carefully. You start from here. At the end, you notice that you're getting a similar expression, and then you move it to one side and you get the final integration. So this is by integration of the parts.